Okay, so I think right now the meeting is being recorded on my device. Later on, I can share it with you. Is anyone else coming? Can you put it on the group?
Yeah, I'll do it now.
Okay, thank you. So I was making these notes for you guys. Possibly it will be beneficial for you. It's still incomplete, but once it's completed, I've put it on Moodle, so as you know, it will help you to understand what is sailings, why it is what, I do what, and then some questions. I'm still making it, but it's still incomplete. Once it's done, I will put it. We'll wait for 3 more minutes and we'll start at 19:10. If anyone wants to join, they'll join, or they can join at a later stage. Anyways, let's start. Yeah, those who want to join will join at a later stage. Okay. So, okay, just let's see what we did yesterday. Yesterday, we did sailings, and we started off with parallel sailing, plain sailing, and Mercator sailing. So I hope everything is clear with these three types of sailings, which is parallel, plain, and Mercator. So we'll right now start with great circles again. So we did little bit of it yesterday, but we are going to restart it from the scratch, from the beginning. So great circle is basically shortest distance between 2 points. And most important thing is it may not be a straight line. Okay, so if this is point A, this is point B, this is the equator, this is your North Pole. The great circle will take the curvature of the Earth. So if you are in northern hemisphere, okay, so Segan has come up. So if you are in northern hemisphere, the great circle will move initially towards the North Pole. The arc will always bend towards North Pole. So it is going to be like this. What I meant by that arc will always bend towards North Pole, I mean to say that this one is never going to be the case. It has to come and bend towards North Pole, right? Let's look at the formulas again and what all things we need to calculate for the great circle. So number one is basically the distance. You can use formula of blue folder, but be very much careful that this formula takes distances from pole. And we can also use another formula for calculating distance, which we are usually taught, in college. Here, the important thing what we need to know is the addition or subtraction sign. This thing and this thing is really important to remember. If you are using the formula for the blue folder is measures the distance from the pole. And if you're using formula which we are taught in the college, which is basically the cos of d long times cos of flat A, cos of flat B plus minus sine of flat A, sine of flat B, then we need to take at most, we need to give most attention to the plus and minus sign in the formula. Let's look at the formula in blue folder. So formula in blue folder is cos of AB time equals to cos of D long, or you can call it as angle P, multiplied by sine of PA multiplied by sine of PB, and it is plus cos of PA multiplied by cos of PB. This is all in brackets. This bit, PA, PB, wherever it is mentioned, I've highlighted here. This is really important because these are not latitudes. But these are, these are not latitudes. These are distances from pole. So if I say my position A was 10 degrees 00 minutes north and 010 degrees 00 minutes east. So PA will actually become 90 degrees minus latitude. The reason is, I'll make a new drawing here. This is A, this is B, this is your pole. This is your equator. This is lat A. And this is lat B. Now, when we say lat A was 10 degrees, that means measured from equator, it was 10 degrees. We know from equator to pole is 90 degrees, but in formula, we measure this line PA, or if I say this bit. So this was 90 degrees, this is 10 degrees. We can clearly say that this distance is nothing but 90 minus 10. So this is important, that these distances are measured from pole. Now let's look at the formula which we are usually told in the colleges, or I'll just say college formula. The college formula is cos of distance equals to cos of d long times cos of lat A times cos of lat B. These are all in brackets, plus or minus. This thing is important. again brackets, it is sine of lat A multiplied by sine of lat B. This is the formula which we learn in the college. So in this formula, what is important is to remember when to use plus and when to use minus. So if you have both your latitudes in same hemisphere, we use plus, and if both latitudes in different hemisphere, we use minus. This is the only thing which we need to remember if we are using any of these formulas. You can solve with any of these formulas, you will get exactly the same answer. The second thing, what we need to find out during great circle is the initial course. The initial course we solve by ABC method. This is the same method what we use for obtaining the true bearing when we are calculating the compass errors. The same method. So A is basically tan of lat A over tan of D long. B is sine of lat A. Sorry, B is tan of lat B over sine of D long. C is equals to A plus minus B, and tan of azimuth is equals to 1 upon C into cos of lat A. Now, the next important thing is the name, how we do the naming. Naming for azimuth. This is again, I would like to tell you, this is all we are doing for the initial course. So let's look at how we do naming for A. Naming of A is determined by what is our D long. If D long between 90 and 270 degrees, then same as latitude A, else opposite of lat A. So if our D long is 110 degrees, then let's say the naming of latitude A was north. So it will be north because it is between 90 and 270. If our day long becomes 75 and the latitude of A was north, then it will become opposite of north, which is south. Now we'll look at naming for B. It is always same as latitude B. If latitude B is south, your naming for B is south. If latitude B is north, the naming of B is north. And let's look at naming for C. Naming for C is same as whichever is greater among A and B. So if I have got a numerical value for A as, let's say, 0.5000, and I have got a numerical value of B as 0.300 south, and A was 0.500 north. So the numerical value which is bigger among A and B is for A, which is 0.500. This is the bigger one. So the naming would be same as A. So A was 0.500 north, B was 0.300 south. So C name would be north. Now, naming for azimuth. So I'm talking about here. So once you have calculated azimuth, you will have some value over here. We need to name azimuth north or south over here, and east and west, east or west over here. So whatever is the naming for C comes here. So if C is, let's say, north, it comes north. If C is equals to south, this comes as south. So it is same as C. Now, how we need to determine east or west, which is supposed to come here. So if we are going in, let's say, this direction, or something like this direction, or something like this direction, we are actually moving in east. If we are moving something like this, something like this, something like this, we are actually moving in west. So whatever direction we move in, that is the name here, which is east or west. So this one is in direction of movement. So this was how we calculate the initial course. Now let's look at how we calculate the final course. Final course is, again, we use the ABC table method. So A is equals to tan of lat B this time, because if you look at this drawing, we have to use this as our initial position now, and this as the final position. So our initial position in final course would be lat B, and our final course, final position would be lat A. This is the assumption we make. We know that we are going from A to B, but in order to calculate this final course, we have to make an assumption that we are moving from B to A. So this would be tan of lat B over tan of D long. P is equals to tan of lat A over sine of D long. C is again same, everything remains same, A plus minus P, and tan azimuth is equals to 1 upon C into cos of our initial lat. So in this thing, we assume that our initial lat was lat B. Now the next step is again naming for them. So naming, we need to know what is and how we do the naming. Now we'll see the naming of each of them one by one. So I would say naming of A. So again, the same principle. If your D long is between 90 and 270 degrees, then same as your initial lat. So in this particular case, it was lat B, because we had assumed that we would be going from B to A. Naming of B. So it is always same as your final lat. In this case, we had considered our final lat as lat A. So whatever is the name of lat A, that will be the naming of B here. Now naming of C. Again, it is named in the same way as we did for finding the initial course. So whichever has, among A and B, whichever has a bigger numerical value, the naming of C goes with that name. So if A is having a numerical value, in this case, I would say 0.300 naught, and B is equals to 0.500 south. So in this case, B was bigger. So the name of B will come here. So I would say whichever is bigger between A and B. Now it is naming of azimuth. So naming of azimuth, you will have some value here, and you have to name again north or south over here and east or west over here. Now, what comes here in when we were finding the initial course was exactly the name of C. But when we are finding the final course, this is not the way. We need to take whatever is opposite of C. So if C was south, we'll put north here. If C was north, we'll put south here. And this direction, east or west, depends upon in which direction we were moving. Actually, we were actually moving from A to B, but when we were solving for calculating final course, we assumed to move from B to A. So this comes from the direction where we are actually moving. So we were actually moving, if we are actually moving in east, it comes east. If we are actually moving west, it comes as west. We will not take, like we made an assumption here, that we are actually moving from B to A. In this case, it was west. So we'll not write west because we assumed this thing while calculating the final course. Our actual direction is still moving east. So we'll write east when calculating the final course. So this is opposite of C, and this is actual direction of movement. This is important because usually people make mistake over here while solving the questions, because while calculating the final course, we had assumed, we had made an assumption that we are moving from B to A. But we need to put the direction in which we are actually moving. We are actually moving from A to B. So this is an important stuff to remember. So this was about how to find out our initial course, our final course, and the distance. So do you have any doubts with respect to this, Segan? Segan, are you clear up till this? Okay, Mark?
Yeah, I'm
okay. Okay.
Okay,
Michael?
I can hear you.
You can't hear me?
Yeah. I muted that.
Hello, Segan? Michael, can you hear me?
Yep, all good here.
Okay, Michael, have you understood up till this point?
I think so.
Yeah, okay. Gursimran? Okay. Segan, are you facing some troubles in hearing me? Okay, anyways, possibly I think Segan is facing some troubles in hearing me. Later on, I'll share the class video with you guys. Okay, now another important point with respect to great circle is the vertex. The vertex is a point where your course would be 90 degrees or 270 degrees. That's the point. Some people say that vertex is actually the highest latitude that is achieved during the passage. It may not be the case because of the following reason. Now let me plot you a diagram for this. Now you are at point A, this is point B, and you are doing a great circle up till point B. After this, I would imaginary extend your course, which is like this. This is the point where we would lie, because if we reach at this point, our course would be 0, 9, 0. But if we look at the definition where some people say that it is the highest latitude achieved during the passage, then the highest latitude achieved during the passage is B here. So B is actually not the vertex. The property of vertex is that among all the positions A, B, and V, it is the highest latitude towards, towards the pole. It is not the highest latitude between 2 points. So in simply defining vertex, it is a point where your course is 90 degrees or 270 degrees, right? Okay. Now, let's look at another drawing, which is point A is here, point B is here. This is our pole.
How was your? I'm still busy. How was your?
Segan, you are saying something?
Okay. Sorry. Not you. I was not talking to somebody else. Sorry.
Okay, right. No problem. In this case, if we see, this is somewhere the point where our course would be actually 090. So our vertex has to lie somewhere here. This is the longitude of vertex. This black ink is the longitude of A. This green ink is the longitude of B. Now, since our course is 90 degrees or 270 degrees at vertex, that means that this angle would be actually 90 degrees. Because what happens when we do a course of 90 degrees or 270 degrees is we are actually running on the latitude. So we know that if we are running on a latitude and there is a longitude like this, latitude and longitude always intersect each other at 90 degrees, like this. So this has to be 90 degrees. Mark it as this. Now, whenever we have a spherical triangle is this or this. Whenever we have a spherical triangle, we use certain formulas. And if there is a right angle spherical triangle, which is this, then we use the easiest way, that is the Napier's wheel. Now let's plot the Napier's wheel for this triangle, P, V, and A, which is right angled at V. So this was V. I always decide to go clockwise. So this always needs to move also clockwise. So this is the point V in the triangle. This is the point V in the Napier's rule. So when we move clockwise, this is the first thing what we get. So we'll write VA. The next thing, when we move clockwise further from VA, we get angle VAP, or I would say angle A. The next thing, when we move clockwise, we get is AP. The next thing comes up is angle APV. And the last thing comes up is PV. After PV, we have again reached V. So we have again reached V. We know that all these three places which are in the second half of the semicircle, it is all 90 degrees minus. So this is 90 degrees minus, this is 90 degrees minus, this is also 90 degrees minus. Now Napier's rule says sine of midpart is equals to tan of adjacent 1 times tan of adjacent 2, and sine of midpart is equal to cos of opposite 1 multiplied by cos of opposite 2. Now let's say we need to find out PV, and we see PV in Napier's wheel is here. So for PV, the adjacents would be this side and this side. This side will be opposite and this side will also be opposite. If we need to calculate VA, then this would be adjacent, this would be adjacent, this would be opposite, and this would be opposite. The same thing can be done with any of these values. After this, we will make the Napier's wheel for the triangle PVB. So let's make the Napier's wheel for PVB. Again, it is right angled at V here, and I will decide to move clockwise. If I move clockwise, this has to move also in clockwise. So after V, the next thing which comes up is VP, then it is angle BPB, then it is PB, then it is angle B, then it is BV. After BV, we have again reached point V. So after BV, we have again reached point V. All these things in the second half of the semicircle are 90 minus. So I will write it straight away: 90 degrees minus, 90 degrees minus, 90 degrees minus. If I want to calculate VP, in this case, the adjacent would be these two sides, and this side would be opposite, and this will also be opposite. If I need to calculate this bit, this will be my adjacent, and these two sides will be my opposite. The entire formula for this wheel also remains same, this one. So if we need to find out any of these values in a right angle triangle, in great circle, you will always have the right angle triangle. We'll always use the Napier's wheel. Right. Now, in the questions, it is usually asked to find the position of the vertex, this one. Now, if we say the position, they are asking you a latitude, which is basically measured from the equator, and its longitude, which is basically measured by angles which are subtended at the pole. If I make this diagram again, I will simply copy this diagram, I'll paste it. I will enlarge this image. I'll make a line for the equator. So this was my equator. Now I need to calculate the position of vertex, which is this part. So I need to give a latitude and a longitude. So latitude is basically what is the distance from the equator, and longitude is basically the angle subtended between the Greenwich meridian and your longitude. So it is basically this angle. And usually, most of the cases, you will always be knowing the position of A. That is, you will be knowing both lat and long of A. And for B also, you would be knowing lat and long. If this part was my longitude for A, and if I'm able to find out this angle, I would be able to calculate the longitude of V. If I'm able to calculate the distance from pole to vertex, then all I need to do is 90 degrees minus PV will give me the lat of V. Because from pole to equator, it is 90 degrees. And if I'm able to calculate this distance from pole to V, I can simply do is this entire distance minus this distance. So how we calculate vertex? As I said, you will be given always with the position of A, that is lat and long. So you will always be knowing your PA. If you want to solve it with this triangle, then you will always be knowing PA. So I will say, I'll just copy this Nepier's wheel down. Okay. So always I will be knowing the PA side, which is PA or AP. So I'll be knowing this bit. You would have already calculated your initial course. So initial course is basically this angle, so which is angle A. So you would be knowing this bit. In Nepier's wheel, if you know two things, any of the two things, in this case it is this and this, we will be able to find out all these three things with only these two values. We can find out all these three things. So when we say we need to find out PV, we can simply use the opposite formula, because for calculating PV, this was the adjacent, this was the adjacent, and this was the opposite. So we will simply use the formula, which is sine of mid part is equals to cos of opposite 1 times cos of opposite 2. You can name anyone as opposite 1, and you can name the other whichever is left. So it can be 1, it can be 2, or anything you can name. 1 can be given to anything. So this is how we'll be getting the value of PV. Once we have achieved the value of PV, we can simply say 90 degrees minus PV will give me the lat V. So we have found out the latitude of vertex in this way. Now all which is remaining in this type of great circle questions is to find out the longitude of V. As I said, that we will always be knowing the position of A. So we'll be knowing the lat and long. So we will be knowing this long. If I'm able to find out this angle, I will simply add this angle to the longitude of A and get my longitude of V. So let's look what this angle is. This angle is actually APV. So this is the angle APV. Now to calculate this, as I said, if we know any of these two values, with using those two values, we can find out the remaining three things in the Napier's wheel. So I would say this as my midship part. This becomes my adjacent. This will also become my adjacent. This will become my opposite, and this will become my opposite. So I will use the midship of AP times tan of adjacent. So I will write it as sine of, which is 90 minus AP. So sine of 90 minus AP is equals to tan of adjacent 1. I can take this or I can take this. So I will now take this. So this is 90 minus angle APV. Let's say tan of 90 degrees minus angle APV times tan of 90 degrees minus angle A. So tan of 90 degrees minus angle A. We were supposed to find out this angle APV. We already know AP and we already know A, which is our initial course. We need to transpose this formula now. So we can write now as sine of 90 minus AP divided by, so this bit will come here in the denominator part as tan of 90 degrees minus angle A equals to tan of 90 degrees minus angle APV. If you are using a calculator which is having a solve function, you don't need to transpose this formula. You can simply put the values of AP and angle A here, and as you press solve in your calculator will straight away give you the angle APV. So don't need to transpose if you're using the solve function. If your calculator doesn't have solve function, then you need this transpose. So this is how we calculate the position of the vertex. So we will now solve one of the questions from the college tutorial. I've already sent that list of questions to you on the WhatsApp group. And we will now solve question number 1 again from that tutorials which I've already sent you in the WhatsApp group. So it says, calculate number 1, the distance. Number 2, the initial course. Number 3, the final course. And number 4, the position of vertex. So we have already learned how we calculate the distance, how we calculate the initial course with the ABC tables, and how we calculate the final course again with the ABC tables. and how we calculate the position of vertex with Napier's wheel. Only these 4 things can be asked from you in an examination, which is either HND or SQA. Only these 4 things. So you just need to know how to solve for these 4 things. So let's begin solving the question. So I'll start it from the new page. So question 1. So my position A, as I said, it will always be given to you. It is 35 degrees, 03 minutes south, and longitude is 056 degrees, 17 minutes west. Position of B is 34 degrees, 30 minutes south, and 017 degrees, 20 minutes east. Now we will draw the diagram for this problem. We are going from A to B. Now we can clearly see that we are moving from 35 degrees south, approximately 35 degrees south to approximately 34 degrees south. So we are moving towards north. So if this is my A, I need to put my north, my B position, which is north. Now, if we look at the longitude, which is 56 degrees, 17 minutes west, we are moving towards 17 degrees, 20 minutes east. That means we are moving towards east. So point B needs to be slightly up as compared to A and east of point A. So it has to be somewhere like this. You will always have a pole in this, you will always have a pole. In this case, it is South Pole because all this thing is being in the southern hemisphere. So I'll name it as pole P. So this was the great circle, what we were doing. This green ink is the longitude of A, and this blue ink is the longitude of B. We still cannot say where that vertex is because, as I said, that vertex may happen at the imaginary course which is drawn before A, or it can take place at an imaginary course if you extend that same course after B, because the course needs to be 90 degrees or 270 degrees. If your initial course and you have your final course, if you are not having a course between your initial course and your final course, you cannot find the value 90 degrees and 270 degrees, then your vertex will not lie between A and B. To determine this thing, whether the vertex lies in our path or on a virtual path before A here or on a virtual path after B, we need to first calculate the initial course. So step 1, I would say always we need to do this step. Step 1 is to calculate the initial course. Initial course, we calculate it by the ABC method. So we'll use the same method. So for me, A is equals to tan of my initial lat. So my initial lat is tan lat A and over tan of D long. My lat A was 35 degrees, 3 minutes. I'll write it as 35 degrees, 03 minutes. And my D long was 56 degrees 17 minutes plus 17 degrees 20 minutes, which is 73 degrees 37 minutes, which will give me an answer of tan of 35 degrees 3 minutes divided by tan of value of 0.20624. Now naming. As I said, if your D long is between 90 degrees and 270 degrees, then it is same as initial lat, else opposite. So in this case, D long is not between 90 and 270 degrees. It's less than 90 degrees. So it has to be opposite of initial lat. So my lat A was south, so naming would become north. B is calculated by tan of final latitude, which is lat B in this case, over sine of D long. So it is lat B is 34 degrees 30 minutes divided by sine of 73 degrees 37 minutes, which will give me an answer of tan of 34 degrees 30 minutes divided by sine of 73 degrees 37 minutes. 0.71637. Now, the naming of B. So it is always same as your final latitude. So your final latitude was B here, whose name was south. So it will be south also. I would say south. C is A plus minus B. That means whatever you have a greater numerical value, you need to take smaller numerical value from that value. Your greater numerical value can be A, it can be B. If it is A, you need to take the smaller numerical value out of A. If your numerical value of B is greater, then you need to take A from B. Here, the value of B is greater. So I need to take out value of A from this part. So it is 0.71637 minus 0.20624. We have used the subtraction sign because both these names were different. So you use minus sign if you have different names for A and B, and you use plus sign if you have same name for A and B. So we had different name, north and south, so we have subtracted. This gives me a final answer of 0.71637 minus 0.20624, which is 0.51013. Now, I think I've just got disconnected. Just a minute. I'll reconnect this thing. Just a minute. Mark, are you still receiving this EduRIMS
Yeah.
Wi-Fi network?
Yeah, can I hear you?
Are you still receiving this EduRIMS Wi-Fi network?
Yeah, I'm still receiving the Wi-Fi.
Okay, just a minute. Just give me a time because my tablet has been disconnected. Just a minute. I'm just trying to reconnect.
So
Okay. Can you guys hear me?
Yeah.
Yeah.
Okay. So you can see the screen?
Yes.
Okay, fine. So we had reached in calculation for C. So C was basically the numerical difference between A and B, which we found out to be 0.51013. And the naming of C is done in, whichever is bigger from not, whichever is bigger between A and B, that's the same name for C. In this case, it was the value of B, which was bigger. So it will be the same name, which will come here. Now the next step is to calculate the tan of azimuth, which is equals to 1 upon C over cos of your initial lat. So in this case, it was latitude A. So this will give me the answer of multiplied by cos of 35 degrees, 3 minutes. 1 divided by the answer. 2.39453, and the value of azimuth will be calculated by tan inverse of 2.39453. You will get an azimuth of 67.33368, right? And now you need to do the naming for the azimuth, which is north or south over here and east and west over here. So this name is same as C. So our C was south. So this would be same as C. So if this is south, it will also be south. We were moving in an eastward direction. So here, since we are moving in east direction, we have to write as east. So I would write it as east. So my initial course is given by 180 minus this answer, which will give me 112.5 degrees true. This will be my initial course. So how are you feeling up till this point, guys? I can't, Mark, how up till this step, till finding the initial course, are you fine?
I was all right until I got to C, and then when it comes to the tan azimuth, 1/c times the cos of lat A, I get different values. So I've got 1 divided by 0.51013.
Have you used the brackets, which is 1 divided by bracket, then it is C times cos lat A, then bracket close in your calculator.
I'll try that now.
Okay, just try. Manfred, how are you feeling about this?
Yes. I understand very well to this point. Very well.
Okay, fine. Then the next is Sigyn. How are you feeling about this up till this point?
Okay, I'm okay. I'm okay.
Yeah, okay, very good, very good. Michael, how are you?
Okay, I think.
Okay, Gursimran? Gursimran, how are you feeling up till this point? Okay. So Mark, did you got this answer? Mark?
No, I'm getting 1.6 something.
Okay, let me try. Maybe I have made a mistake. So it is C was 0.51013 times the cos of my initial latitude, which was 35 degrees, 3 minutes, divided by answer. What are you getting?
Hang on a second, I'll just do it now.
Okay, no problem. I will just share my calculator and tell you how it's to be done, okay?
Yeah.
Okay, just a minute. I need to stop my screen share for this. Okay, so switch the cameras. Right, Mark. Mark, can you see my calculator?
Yeah.
Okay. So I'll just put the value of C, which was, can someone tell me please, what was the value of C? Okay, the value of C is 0. It is 0.51013, right?
Yeah.
You were supposed to.
I can't see your screen now, by the way.
Sorry?
I can't see the screen now. It's gone to white. That's it.
Okay, now?
Yeah.
Okay, so what you do is you need to do the equation, which is 1 divided by C times initial cost lat. So I would say I will do 1 divided by C, which was, my answer, times the cos of latitude, which is 35 degrees, 3 minutes. You see this?
Yeah.
And this will give me an answer of 2.39453.
Yeah. Okay. I must be putting the brackets in wrong. Okay, I'll play with that in a minute.
Okay, right. So I'll share the content again. Okay, so I'm again starting with screen broadcast. So we have got our initial course. Now we need to calculate the final course. Okay, so final course, again, we use the same ABC method. So it is A is equals to tan of initial lat, because here now we'll assume that we are moving from B to A. We'll assume that. So for this will become point B will become our initial latitude, and point A will become our final latitude. So it is tan of my initial latitude, which is lat B, over tan of D long. So this will give me tan of 34 degrees, 30 minutes, divided by tan of my D long, which is 73 degrees, 37 minutes. So the answer what we will be getting would be tan of 34 degrees, 30 minutes, divided by tan of 73 degrees, 37 minutes. So this will be equals to 0.20206. Now the next step comes as the naming. Now naming, again, if the D long is between 90 degrees and 270 degrees, then it is same as initial lat. So it is not between 90 and 270 degrees. So it has to be opposite of initial lat. We had assumed that we are moving from B to A. So our initial lat is the point B. So the point B is south. So it has to be opposite of south. It has to be north. So B is equals to tan of final lat, which is the lat A, over sine of D long, which is equals to tan of 35 degrees, 03 minutes, divided by sine of 73 degrees, 37 minutes, which will give me tan of 35 degrees, 3 minutes, divided by sine of 73 degrees, 37 minutes, 0.73120. Now again, it is the naming. So the naming of B is always same as your final lat. So in this case, our final lat was 35 degrees, 3 minutes south. So this was south. It will be south here. Now C is A plus minus B. Since both A and B have different name, which is north and south, we need to take them off from one another. If they would have been the same name, let's say south, or north, then we would have simply added them. Now we are supposed to subtract them. Now we'll subtract the higher numerical value from the smaller numerical value. So this is the higher numerical value, and this is the smaller numerical value. So it would be C is equals to 0.20206, 0.52914. Now the naming would be same as whichever is bigger in numerical value in A and B. So if A had a bigger numerical value, it would have been north. And if B had a bigger numerical value, it would be south. In this case, the B has the bigger numerical value, so it has to be south. Now, tan of azimuth is equals to 1 upon C into cos of your initial lat, which is lat B in this case. I would say it is 1 over 0.52914 multiplied by cos of lat B, which is 34 degrees. (30 minutes). This will give me an answer of 2.29317. So we'll now do, which is tan of azimuth. So azimuth is equals to tan inverse of 2.29317. I'll just inverse the values. We'll get 66. 43910. Now naming is, this is opposite of C always. So C is south, here the naming would become north. And since we were actually moving, it's now not what we were assuming, we were actually moving in east. So the same thing is going to come here, where we were actually moving. So it would be east. So my final course would be 0.66½ degrees true. Like this. Now, before we jump in for calculation of distances and vertex, we need to stop for a bit and see what I'm right now, about to tell you, which is going to help you a lot in determining the position of vertex and calculation with respect to vertex. I will rewrite what was my initial course, what I had found out. So my initial course was 112½ degrees true. Shade it in pink. Now, we need to see how this vessel is moving. So the vessel was doing something like this. then probably the vessel would have come like this, then vessel would have come possibly like this, then somewhere like this. So this was our 112.5 degrees, and this is our final 066.5 degrees. Now we can see clearly, like the vessel is initially like this, and then it is course is changing towards north. So it is coming like this, it is coming like this, then it is coming like this. Now there will be one instance when the course would be 090, because the course is changing from 112.5 degrees to 066.5 degrees. So it would be like 111, then it would be 110, then at some point of time it will be 100, at some point of time it will 90, then 80, then 70, then it would be 66.5 degrees. So this is how the course would approximately change. So we can clearly see at some point the course would be 90 degrees, like this. This gives us a clear idea that vertex is going to lie in between A and B. It is not going to lie at a virtual point before A and or at a virtual point after B. If, for example, we would have been having a course of, let's say, initial course of 080, and I got maybe a final course of 040. Now let's see how the course of the vessel would be changing. So 080, it would be like this, then it would be changing like this, then it would be changing like this, something like this, till the point you will come 040. So the course was actually changing over a period of time, which will come as 080, 079, 078, and then at some point of time, at a greater interval, it would be 070. At a more greater interval, it would be 060, then same way as 050 and 040. Now we can see that there is neither 90 degrees, 090 degrees, or 270 degrees is coming in between the initial course and final course, which will tell us that vertex is not going to lie in between A and B. The vertex is either at a virtual point before A or at a virtual point after B. Now, how this is going to help you if you determine it correctly? Now, I will copy this drawing and show it to you. I've enlarged this drawing a bit. Now, if we look at this question, this particular question number 1, which we were solving, we came to know, depending upon the initial course and final course, the vertex was lying somewhere in between A and B. So it is A is here, B is here. It has to lie somewhere in between A and B. So let's assume it's here. So something like this. And we were solving for this triangle. To calculate vertex from Napier's wheel, we were actually looking to find out this angle. Sorry, to find out this angle. And after that, we were supposed to add it in this value or subtract it in this value, depending upon which direction we are moving, east or west, and depending upon which longitude it is, east or west. But if you have realized that the position of vertex not lies between A and B, let's say it lies at a virtual point, which is before A. I'm saying it as a virtual point because you will not do that course. This is a virtual point extending your courses. Then how it's going to help you is, then you need to determine this entire angle and add or subtract depending upon what is your longitude of A, east and west. This is done because you won't be able to use this angle because vertex is not lying in between. If the vertex lies at an imaginary point, let's say maybe after B, so somewhere like this, somewhere here. So what we know is that we won't be able to obtain the longitude of vertex by solving this triangle. So if we are trying to solve this triangle, that is utter waste of time. We are supposed to solve this triangle and get the value of here. Now, in this particular case, the vertex was lying in between A and B. So we'll solve the position of vertex. So let's bring out this drawing again. Copy it. I'll paste it. So vertex in this particular case was lying in between A and B. So I can still solve all the values for vertex with this triangle. Let's look at the Nepier's wheel now. This is point wheel. I always decide to go clockwise. So my triangle also needs to go in clockwise direction. And my Nepier's wheel also needs to go in clockwise direction. So this was my right angle V. So the next or the first thing comes after V is VP. The next thing comes is the angle VPA. The next thing comes up is PA, then it comes as angle A, and then it comes as AV. We know that everything in the bottom half is 90 degrees minus. I'd say 90 degrees minus, 90 degrees minus, 90 degrees minus. Now, what all things in this Napier wheel we know? We know the value of PA. So we know this arc, this part, and we know our initial course. So we know this bit also. Now, what we are looking to find out first is the latitude of vertex. So which is by calculating this. So which is this part, VP. So I will mark it as a tick mark in front of it. We know this, and this is my mid part. So if this is the mid part, this becomes my adjacent one, this becomes my adjacent two, this becomes my opposite one, and this becomes my opposite two. So we can clearly see we know the opposite values. So we'll use the formula for opposite. So I'll write it as sine of mid part, which is sine of VP, is equals to the cos of opposite, which is 90 degrees minus angle A, times cos of 90 degrees minus PA. So cos of 90 degrees minus angle A. So angle A was our initial course. Now there is something important which I'm going to tell you right now with respect to the SQA examinations with respect to angle A. When we found out our initial course, which was this value, which has been rounded off. When you are finding something which involves the initial course, you are finding something, in an equation, you are finding something which involves initial course, we are going to use the most precise values, which is this value, including all these decimals. So we are going to use 67.3368. We will not use the rounded off value because we are carry forwarding the calculation from the initial course. We will use 67.33368, which is 67.33368 times cos of 90 degrees minus PA. So I will write it as 90 degrees minus my PA is the length of position A from pole. So I will write it as 90 degrees minus lat A and close the brackets. Let's solve and see what is this value giving. So I would say 68 times cos of, now when we open up this bracket, it would be 90 degrees minus 90 degrees plus the angle, which is not the angle, plus your latitude. So we know 90 degrees minus 90 degrees is 0. So they get cancelled off. So whatever is remaining is cos of 90 degrees minus 67.33368 degrees multiplied by the cos of lat. In this case, it was A, right? Let's solve and see what is the value of VP I'm getting. So I'm getting 90 degrees minus 67.33368 degrees and cos of answer multiplied by cos of lat A, which is 35 degrees, 3 minutes. So I'm getting this as 0.75542. This is sine of VP. So VP will be equals to sine inverse of 0.75542. So VP is sine inverse, which will give me 49 degrees 04 minutes. And this value is rounded off to nearest minute. Latitude is rounded off to the nearest minute. Now VP is this distance which is measured from pole, but we need to give the position of V, which is the latitude and longitude. We know that from pole to equator, it is 90 degrees. And we now know that from pole to V, it is 49 degrees, 4 minutes. So we can find out the distance from equator to V, which will be nothing but the latitude of V. So we'll write lat of V is equals to 90 degrees minus 49 degrees 04 minutes, which is 40 degrees 56 minutes. Now, since everything was in southern hemisphere, so the latitude of V or the naming of V will be same as south. So we'll write it as 40 degrees 56 minutes south. Now we have calculated the latitude of V. Now we need to calculate the longitude of V. So I know my longitude of A. if I'm able to calculate this angle, then I know that this value needs to be added or subtracted depending upon which longitude this was. If it was east or west, then it depends upon what we are supposed to do with respect to addition or subtraction. Let's see in the same Napier's wheel. Now I'm supposed to find out this angle, which is VPA. So it is this bit. As I said, whenever we are solving anything with respect to Napier's wheel, we need to solve everything with respect to two values which have already been given. It is done to get the accuracy of the answer. We can assume that, right now we have got the value of VP. If I say, let me mark it with a darker pink color. We may have got the value of VP here, but we will ignore this because of the accuracy of the answer is concerned. We'll only deal with whatever we had initially. So we had this and this, and we need to find out this angle VPA. This. So if I say this is my mid part, then this becomes my adjacent one. This becomes my adjacent 2, this becomes my opposite 1, and this becomes my opposite 2. So I can clearly use the adjacent formula where I can say sine of this mid part is equal to tan of this adjacent value multiplied by tan of this adjacent value. So we'll rewrite the formula again. I'll say sine of 90 degrees minus PA is equals to adjacent 1, which is, this was the mid part. So adjacent 1, it's this. This is 90 degrees minus angle BPA, just tan of 90 degrees minus angle VPA times this part, just 90 degrees minus A. So multiplied by tan of 90 degrees minus angle A. We'll put in the values, which is 90 degrees minus PA was nothing but 90 degrees minus lat A. Because PA is the distance measured from pole to A. So we need to do is to determine PA, we'll do is 90 degrees minus lat A. This is equals to tan of 90 degrees minus angle VPA, which we need to find out, and tan of 90 degrees minus the initial course. So this is the initial course. As I said, we are supposed to take this value. We cannot take this value. So this is 67.33368. We write it as 67.33368. Now solving further, when I say, let me open this brackets, this one. So I would write it as tan of 90 degrees minus 90 degrees plus lat A, because this minus times minus becomes plus here, which is equals to tan of 90 degrees minus angle BPA, which we are supposed to find out, multiplied by tan of 90 degrees minus 67.33368. 8. Is it 68 or was it 48? So it was 68. Right. Now, if you have a calculator having a solve function, then the thing is quite simple. You just need to put in this equation and it will automatically give you the value of VPA. It's always better to have that calculator with the solve function if you're struggling with transposing the formulas. If you are not struggling, if you do have no problems with transposing the formulas, you can use the normal calculator without a solve function. So let's solve without the solve function by using the transposing the formulas. So 90 degrees minus 90 degrees, it's nothing but 0 degrees. So I would write it as sine of lat A is equals to, now this entire bit will come down in the denominator. So which is tan of 90 degrees minus 67.33368, which will be equals to tan of 90 degrees minus angle VPA. So we'll just put in the value of lat A. So value of lat A was 35 degrees, 3 minutes, divided by tan of 90 degrees minus 67.33368 degrees, which will give me tan of 90 degrees minus angle of VPA. So solving on this, we get sine of 35 degrees, 3 minutes, divided by tan of 90 degrees minus 67.33368 degrees. We'll get an answer of 1.37516, which is equals to tan of 90 degrees minus angle VPA. So tan inverse now 1.37516 will give me 90 degrees minus angle VPA. So this is equals to 53 degrees, 59 minutes equals to 90 degrees minus angle VPA. So what I will be doing is again retransposing the formulas. So this minus VPA goes here and this value will come here. So this will give me positive of angle VPA equals to 90 degrees minus 53 degrees 59 minutes, which will give me 90 degrees minus answer as 36 degrees 01 minutes of angle VPA. I'll highlight this bit. Now let's look what angle we have got. We have got this angle. Now we know that longitude of A is 56 degrees 17 minutes. I'll just write down the longitude of A, which is 056 degrees 17 minutes west. We now know that we are moving easterly. So this has to reduce. So it will be, the longitudes will come as 55 degrees, then it will come as 54 degrees west, then eventually coming up at 50 degrees west and so on. So it is actually reducing because we have the longitude west and we are moving in an easterly direction. So what we would do is, I would say long A is equals to 056 degrees, 17 minutes west. We now know that angle VPA is supposed to be subtracted because we are moving east. So which is 36 degrees, 01 minutes. So this will give me 16 minutes west, 0 to 0 degrees, 16 minutes west, which is my longitude of vertex. So I will highlight this bit. This is how we determine we need to add or subtract. If let's assume that the longitude of A instead of west was east. Now we are moving east also. So in this particular case, what would have happened was that angle VPA would have been added. Now in this case, the longitude is west and we are moving east. That's why the angle VPA is subtracted. This is the reason. So the position of vertex is, the latitude is this, 40 degrees, 56 minutes. So I would write it down. Position of vertex is 40 degrees, 56 minutes south, and the longitude is 0 to 0 degrees, 16 minutes west. This is the final answer for position of vertex. So
please, can you?
Please, yeah, Manfred?
Yeah. Please, can you come again with your explanation why you subtracted angle VPA, please, again?
Okay, right. Let's look at this drawing again. Okay. I have written the longitude of A, which is 56 degrees, 17 minutes west. We are moving in a direction which is easterly in nature. So if I say this was, I will make up a diagram. Let's say this was 56 degrees, 17 minutes east, this one, and you are moving in an easterly direction. So the longitudes would keep on reducing. So this would become 50 degrees, this would become 40 degrees, this would become 30 degrees, and then you will have a Greenwich meridian, and then you will again come to 10 degrees east like this. So here, the longitude was 56 degrees, 17 minutes west. We are moving in an easterly direction. So the longitudes would be like 55 degrees west first, then you will come with 54 degrees west, something like this. And then possibly if you take at a greater interval, then you will reach it as like 040 degrees west, then it will come as 030 degrees west. That's why, that is the reason that we have actually subtracted this angle VPA from the longitude, because the longitude is west, you're moving in an easterly direction. If this longitude would have been east and you would have been moving in an easterly direction, then your longitudes would have increased. In this particular case, then you would have added the angle VPA. You got it?
Very well, very well.
Very well, right. Okay, so Michael, how are you feeling about this? Michael? Okay, no problem. Sigurd, how are you feeling about this after the position of vertex?
Okay, I'm okay. Thank you.
Okay, very good. Right.
Sorry,
Now
I'm fine. I just didn't have the microphone plugged in.
Okay, Michael is also fine. Now let's look at the last bit, which is calculating the distance. Okay, so once we have done this, we'll basically finish the basics of grid circle. So thereafter, we can start working on composite circles, and possibly we will look on to the exam types question, how they come up, how they are presented. So calculating the distance. We use the formula in the formula sheet, or you want to use the formula, what you have been told in the college, you can use anything. So let's first use the formula, or I would say the college formula. It says the cos of distance is equals to cos of d long times cos of lat A times cos of lat B plus minus sine of lat A times sine of lat B. Now we know that both lat A and lat B lies in same hemisphere. Since they lie in same hemisphere, we would be using the sign addition here. So I'll just rewrite this formula again. I would say cos of distance is equals to the cos of d long. D long was got it, 73 degrees 37 minutes. So 73 degrees 37 minutes times the cos of lat A, which is 35 degrees 03 minutes, times cos of lat B, which is 34 degrees 30 minutes. This is everything in one bracket. We use the addition sign, times sine of lat A, which is 35 degrees 03 minutes, multiplied by sine of lat B, which is 34 degrees 30 minutes. This is again in bracket. Now again, if you have a calculator with this solve function, you can straight away put this equation and the calculator will directly give you the answer for the distance. You don't need to do anything. But if you don't have the solve function in your calculator and you need to do it independently, then you can do it independently. So first I would solve this bit. So I'll write it as cos of 73 degrees 37 minutes times cos of 35 degrees 3 minutes multiplied by cos of 34 degrees 30 minutes. This is equals to 0.19030 plus, now I will solve for this value, which is sine of 35 degrees 3 minutes multiplied by sine of 34 degrees 30 minutes, which is 0.32528. So we had cos of distance here. So cos of distance is equals to 0.19030, 0.51558. Distance is equals to cos inverse 0.51558, which is equals to 58.96363 degrees. Since distance is in minutes, I will simply multiply it with 60 and get the answer, which is 3538 nautical miles. So this is my final answer for the distance. For MCA exam purposes, all your distances needs to be rounded off to the nearest mile. You cannot write like 3537.8. This was the answer what I got. So you cannot write this. You have to round it off to the nearest nautical mile for calculating the distances. So this is all we do with respect to great circle. So we had calculated the distance here. We have calculated the position of vertex here. We had calculated the final course here. It has to be nearest half degree. And we have calculated the initial course, which is again rounded off to the nearest half degree. So this is all with respect to the great circle, what we need to know for HND examinations and SQA examinations. So any questions with respect to this from any one of you? So let me start with one by one. Segan, any questions with respect to great circles?
No question for now. I
Okay.
just want to, you can show, maybe later you show us this how to use the soft function on the calculator.
Okay, Segan, what I would request is just send me a photograph of your calculator, because first I need to check whether your calculator has a solve function or not.
The same one with what you have.
Okay, same one. So what I will do is I will make a video and I will put it on YouTube so as everyone can have a look of it. Okay. And I will be telling you the tips and tricks of the calculators, how to store the numbers, how to recall the numbers, how to store the values. Like, you know, sometimes what happens is, I know, like, let's, for example, you know, this is off topic. I know that this D-long is always being used somewhere. So in my calculator, I have my memories in my calculator, 5 different sets of memories. I can store this value in one of the memories and I can recall it wherever I want. So I don't need to write full sentence, which is 73 degrees, 37 minutes, or I need to scroll up on the page. I don't need to do that. You can simply recall it from the memory. So you can do it with like many of these things. You can put your calculator on, let's say, you know, here A, B, C values are supposed to be rounded off to 5 places of decimal. So you can put your calculator where it will automatically round it will automatically round to the 5 places of decimal. You can put that settings in your calculator. So you know that for stability also, there is nothing which will which will exceed more than 5 places of decimal. You can put the settings in your calculator. So I'll make a video very soon on this and I'll share it on the group. Okay.
Okay, thank you.
Oh, you're welcome. So Manfred?
Yeah, good to go for a good second.
Good. Okay, Michael?
Yep, all good, I think.
All right. So I have already messaged the practice questions in the group. I would request you guys to practice those questions. And if you guys have any doubts with respect to those questions, we can solve on the Zoom class or online session. If you guys are okay with this, then we can move on to the next topic, because I don't want that, you know, anything with respect to great circles or Mercator sailing or parallel sailing or plain sailing, there should be no topic which you don't know about among these 4 sailings which we know, because these are very crucial parts. Like question number 1 in SQA examination usually consists about 35-40 marks, and it's usually about one of the questions for the sailings. So we don't need to lose those kind of marks, those easy marks for the SQA examination. So practice those questions, and answers are already in that tutorial sheets. And I have recorded this video, so I'll put this thing in YouTube, and I'll share the link with you guys, so as you know, you can just refresh what we did today. And I'll also share this the link for the notes, you know, on what I'm writing it on my notepad, so as you can always refer it as a PDF of what I did and how I did, right? Right, guys. So I think for today, we have reached our goals. So I was supposed to finish off with my grade circles, which I have did. So from my side, it's all done for the day. If you guys have anything with respect to, or if you need to answer, if you need to ask me anything, you guys can ask me. So anyone with anything, any questions with respect to anything which we have done in last 2 days?
I'm good, Karen. Thanks.
Oh, you're welcome. Right, guys. So if you guys want, we can continue this thing tomorrow evening again, maybe after 5 o'clock anytime. So just, come up with some time and I will host that meeting, right? So you have your own class group. So just discuss off that what time you need to come up and just let me know so as I can schedule my meeting accordingly, right? Right, guys. So I'll just share off the links with you for the notes and for the video. Okay. Right. Then see you. Okay. Bye. Bye,
Thank you.
Manfred.
Okay, thanks a lot,
bye.
Karen. Thanks a lot.
Oh,
Cheers.
you're welcome, Michael. Cheers. Cheers. Right. See you everyone tomorrow.